Okay, welcome back. Homework 22, antiderivatives. A function capital F is an antiderivative of little f on an interval I if, and that came out a little fuzzy, if capital F prime of x is equal to little f of x for all x in I. What that really means is that the derivative of the antiderivative should send you back to the function. So that's like your mental check. Find the antiderivative of the function given when the constant is 0. So let's talk through this one together. I.e., we find an antiderivative by simply thinking backwards. Functions of the form capital F of x equal cos ax plus c have derivatives of the form f of x equals negative a sine ax. So you can also say that functions of the form negative a sine ax have a whole family of antiderivatives of the form capital F of x equals cos ax plus c. Assume the constant is 0. What we're getting at is the antiderivative of this is going to be cos 13x right here. So the antiderivative of negative 13 sine 13x is cos 13x. Why, you say? Again, you're really asking the question, here you say, give me a function whose derivative is this. So check. Check by differentiating. What is the derivative of this? Well, that would be negative sine 13x and then chain rule times 13, which would lead you right back to where we were at the beginning. So what I'm getting at is initially we start by finding antiderivatives, just thinking backwards and thinking about what expression would have a derivative that's equal to this. Okay, now as always, let's see what Wolfram Alpha can do for us. I'm going to go to the live cam here. Here it comes. See? I typed it in, find an antiderivative of negative 13 sine 13x, and voila! It says there's the definite integral, cos 13x. I'm going to see if it'll let me circle it, plus a constant, and they told us the constant is 0. Alright, I'll hit pause as we go to the next one. So we lucked out, and this is kind of a shorter homework assignment this time. It says find an antiderivative for each function and check your answers by differentiation. Well, clearly we know how to cheat on Wolfram Alpha now, but we want to think backwards. So capital G of x is equal to, and just think about, give me a function whose derivative is that. And you're probably thinking x to the negative 5th, right? But what you're also starting to be aware of is, let me erase some of these pen marks here, is that if your function is of the form x to the n, then its general antiderivative is going to be x to the n plus 1 over n plus 1. So let's just kind of think this out. If you think about it, what's the derivative of x to the negative 5th? Well, it's negative 5x to the negative 6, right? So we're seeing that that the derivative of the antiderivative sends you back to this function here. So you check by differentiate. See, it says check your answers by differentiating. Let's just see if you're getting comfortable with this first rule then. So then capital H of x, the antiderivative for part B, well, if we add 1 to negative 6, we're going to get negative 5, right? So x to the negative 5 over negative 5. Okay? So we're just applying that x to the n plus 1 over n plus 1. And then in part C, capital K of x, the antiderivative for little k of x, hopefully you're thinking now, is x to the negative 5 over negative 5 plus, and then the antiderivative of x cubed is x to the 4th over 4. But then it's got that 4 out front, so those are going to cancel and you're just going to be left with 1. So at that point we have capital K of x equals x to the negative 5th over negative 5 plus 1x to the fourth, or just x to the fourth. And then the antiderivative of 4 is just 4x. It's like saying, give me the thing whose derivative is 4. That'd be 4x. So like I said, practice working backwards, but then also, you have this table here as a reference. Like the antiderivative of sine kx is negative 1 over k cos kx. And the antiderivative of cos kx is 1 over k sine kx, plus an arbitrary constant, of course. So, hope that helps. That's just our little light intro into families of antiderivatives. The next chapter, the next post, I should say, on the iTunes course it will be all about integration and anti-differentiation. This is just an initial exposure. Good luck out there.